sorry, on the TC class, on the TC field on an MPLS header. Down here you have a multi-field classifier that can be used, for example, to select some traffic coming from a given MAC address, for example. And I can use the inner, or let's say the multi-field classifier, to set the inner label down here, while the transport label is going to be set by the definition here of class of service 4, tied to the whole LSP. What's a bit confusing is, in this case, both values are the same, but again, they don't need to be the same. They can be, outer label class of service and inner label class of service might also be different, which means as your VPN traffic crosses your backbone, the outer label is going to discriminate how it's going to be treated, and once traffic gets to your P, then it's the inner label that is going to say how traffic is going to be treated. When it comes to load balancing, if you got multiple equal cost LSPs going to the same P, then you will pick one of the LSPs at random. Okay, and you can also set metrics manually if you want. If all of this doesn't suit you, you can actually use a policy to map BGP layer to VPN traffic on a particular LSP. This is extremely useful, especially if you want to transport something which is very time insensitive, like ATM cells, cell relay. That's very often used for this. End of this very short introduction to class of service. I want to stress again that a real life cost design is not trivial at all. And on top of careful design, you also need to do testing with the actual CE devices that you're going to deploy, just to make sure, especially again in cases of ATM, which has got very, very tight cell delay variation limits. Anyway, all of these technologies typically require some tuning on top of normal deployment of this feature. Also, you need to have your schedulers really, really tuned to achieve the best results. Okay, end of this very short module.